This is JEE Advanced 2021 Paper 2, Section 1. This section contains 6 questions. Each question has 4 options, A, B, C, and D. One or more than one of these 4 options are correct answers.
Question 1 from P and C. Question 2 from AMGM inequality. Question 3 from Rolle's theorem and Leibniz rule in limits. Question 4 from differential equation linear form. Question 5 from vectors using dot and cross product. Question 6 from parabola.
Let's start solving section 1 of JEE Advanced Paper 2 Mathematics with Rajiv Mishra sir, right after the short break.
Number 1 is from permutation and combination. If you see here, there are 4 sets are given. S1 is defined by IJK. IJK lies between 1 to 3 and S2. And so S1 is IJK and IJK all belongs to 10. So N is equal to N1. N1 we find here. N1 is equal to, that is 10 into 10 into 10. It's okay. So that is 1000. So undoubtedly this option is correct. For N2, I is always less than J plus 2 and J plus 2 is lies between I and J, this one. That is, let's say I, and for N2 that it implies, let's say this be I and this what we call J, and let me tabulate this. I is chosen as 1, then J will be chosen for how much number? So let's say for I that is 1, and here then J will be, J have a 8 choice. If over here, then J has 7 choices, right? And J has, and if I has 5 choices, then J will have. Similarly, you have to think about. Now let's see. So one by one, you just submit these values. So if I has 4 choices, so if we have a 7 choices for I, and what about this one for 8 choices for I over here? That is 3 there. Now let's think about this one. So N will create like 1 plus 2 plus 3 plus so on up to 8. And plus 8 choices for this one. As N2 we get here, this one, that is 36, 1 to 8. You can use this like sigma of 8. So 8 into 9 upon 9 4 is 36. So that is 36 plus 8, and that is equal to 44. So this option is also correct. If we see here, that is first option is correct. Okay, so first option is of course 1000. This is correct. Second option is also correct. Think about third and fourth option. So let's see about third and fourth option, about N3. What about N3 here? Let me think about this one, N3. So as N3 is, we got here 210. Now what about N4? Let me see for N4. So we can think about as N4 as here, that is for N4, that is 10C4, okay? Because in N4 IJK L are there. So in this situation, that is 10C4 into factorial 4 ways also there, because in different 4 positions we can permute this also. So this will be 50 40, fine. So 10C4 into factorial 4, that is 10P4 actually, 50 40, fine. And but we have to find N4 divided by 420, we get 420. And so in this way we can see that this option is also correct. So A, B, D options are. So finally the answer is what we will declare. Okay, so let's see, this is the answer. We can recall over here. So okay, it's opposite sides, right? So better just first of all draw the triangle at least. Let me draw the triangle here, over here. That is, let's say this is P and this be Q and this be R. Okay, this be R. So opposite to P, the side is a small p, and here that is small q, and here that is small r as per problem. And this is also a way traditionally we write. So if we consider A option, then what will we think over here? So cos P r square and minus P square upon what do we say here? So by using A plus B whole square formula, we can write instead of equality, we can say make inequality, because so we can write here for Q square plus, and as you know, that is AMGM inequality. Here we are using over here. So that is minus P square plus R minus P square. So in this Q square plus R square, we can say 2QR by using AMGM. We usually give students P square upon 2QR, right? So that is the, so A option is correct. So we can think about here, that is in the first situation, that is A option is correct. Okay. A is correct. What about this one, B option? So if we think about B option, so for B option plus, let's say think this is as plus Q cos Q, P cos R and Q cos Q is always greater or equal to, we can say like this way here, that is greater or equal to, say here, cos Q, P plus R cos Q. Okay, opening this one, then we can get like this way, like this way, and here what we say, this is greater or equal to, let's say this is greater or equal, so yes, so that is greater or equal to also, greater or equal to, that is Q cos P plus P cos Q, Q cos P plus Q cos P, right? So the left term will be Q cos P plus Q P cos Q. Now what we think about here, this implies that is P plus Q is greater or equal to R, right? So this will become P, this will become entire P, and this will become Q. So P plus Q, we write here P plus Q, Q plus P. This will become Q. Q is equal to P cos R plus R cos P, and P is equal to Q cos R, R cos. And that is here what we say greater or equal to, that is what we recall here, that is R. So B option is correct. You can say B option is also correct, because here we say, okay, right here B option, and for here we write that is greater or equal. Sum of two sides is always greater than third sides. Now think about this one. First two options are correct. A is correct, B is also correct. For C option, Q plus R by P under root 2 sin theta, like this way we have to say C over here. So now let's think about Q plus R by P. So what we think about, that is Q plus R by P. Let me put our position somewhere else here. Let's see. That is for C option. Let me say Q plus R, right? So Q plus R by 2, that is, if we use sine rule here, then we can say sine Q plus, that is sine R. Okay, and what we will think here, that is divided by, instead of P we can say sine P, and the constant part is iterated. So this we can apply here by using this inequality, that is greater or equal to 2 times of, means AMGM inequality once again, 2 under root of sine, that we say here sine P into sine Q, sine R, no? Yes. So sine Q into sine R, fine. Sine Q into sine R will be incorrect here. So C is in. Now think about D option. So for D option, what we will think? As for D option, we can go for cos Q. As the cos Q is greater than P by R, it is given over here. They are saying that cos Q. Let me write here cos Q, that is greater than P by R. Okay, and this implies that is into cos Q is greater than sine P. Using sine rule, P we can write here sine K sine P, and K sine R, K cancel. So sine P here and cross multiply sine R into cos Q simply. And this implies for Q that we say 180 minus theta, so that is R sine R minus Q. We can write over here that is sine R minus Q, right? So sine P plus R minus Q, and that will be greater, that is 2 sine. So what we will call here 2 sine P, and hence in this way one of the sign is cancelled. So this implies that is sine of R minus Q, this one. So sine of R minus Q, that is greater or equal to one of the sine P cancel, and here that is sine P. So what we will think about here means this implies that need not necessarily hold true if R is less than Q. So we conclude that here need not necessarily hold true for R. So what we will think here, so finally we conclude that that it means that is only the answer will be, hence A and B are only correct. Hence A and B will be only answer. Okay, so let's see. So question number 3 is from function. F domain is given minus pi by 2 to plus pi by 2, and codomain, that is all real number, be continuous function. F0 is equal to 1 and 0 to pi by 3 definite integral is given ft dt is equal to 0. So which of the following? So each and every statement. So we'll go for A statement. As fx minus 3 cos 3x is equal to 0 as at least one solution. At least word and these are conditions is reminding for Rolle's theorem. So we will use for Rolle's theorem. Let's say this be gx. So we will consider this as gx 0 to pi by 3 fx dx, and here we use minus 3 sin x like this. So go for first A part, that is gx is equal to, we can assume pi by 3, that is pi by 3 is given, but 0 to x we have to consider for variable, that is fx dx. You can think about ft also, or you say fx dx, and that is minus, we have to consider sine 3x because its differential will become cos. So therefore by using Rolle's theorem, okay, so therefore by Rolle's theorem, what we say, g dash x equal to g dash x, that is equal to what we write here 0. We can see here that g dash x equal to 0, and which has at least one value of x belongs to 0 to pi by 3 interval, this one. Okay, so finally we say this option is correct. So now we check for B option, equation fx like this way, minus 3x. So once again here we can use here as like Rolle theorem. So that is gx equal to, we have to think about as like 0 to x fx dx, okay, and plus cos 3x and plus 6 by pi x, yes, 6 by pi x. Okay, 6 by pi x. So g of 0, what about g of 0? That is 1, and g of, that is pi by 3 if we recall, and substitute the values. So we get minus 1 plus 6 by pi into pi by 3. So pi cancel, 3 to 6, 2 minus 1, that is 1. So if we say g of 0 and g of 1 is equal to, are equal, so we can see over here, that is here also we can apply Rolle's theorem. Therefore by Rolle's theorem, g dash x at least one value of x belongs to 0 to pi by 3. So what we think here, that is g dash x, we'll recall here, that is by Rolle's theorem, g dash x equal to 0. So if at least one value of x belongs to, that is 0 to pi by 3. So let's see over here, that is, let's recall, let me think over here, that is x belongs to 0 to pi by 3, x belongs to, that is 0 to pi by 3. So what we will think here, that is 0 to pi by 3. It's okay. And here, yes, so that is 0 to pi by 3. 0 to pi by 3. Okay, so B option is also correct. Now check for C option. As we think for C option, so that here, that is limit x tends to 0, x ft dt and 1 minus e this way. So let's go for C option. So for C option, I will do over here. So limit x tends to 0, let's see, and here that is x into integral of 0 to x, that is ft dt, what we see here, and here we can say that is, if you see, the result is 1 minus e power minus x square. So that is 1 minus e to the power that we say x square and here we will divide and multiply with x square, so that we can manage this result x square, and this will be bracket, and this result will go like this way. Limit x tends to 0, and here that is 0 to x and ft dt. Okay, and that's what we say here. This is s, and this is equal to minus limit x tends to 0, and that what we say here, f of 0, and that is equal to -1. So this is using here, we can say, L'Hopital rule. So what we are doing here, by L'Hopital rule we are using this. So we can write over here also that we are using L'Hopital rule. Okay, so let me write this using this by L'Hopital rule, and we can show this all. Okay, fine. So C option is anyhow. So A, B, C, 3 options are correct. What about D options? Let's see D options. Think about D options. Let's see over here. What's D option is here? That is sin x integral of this one, 0 to x ft dt. Once again, same here. You have to apply L'Hopital rule. So by using this one L'Hopital rule, here also we will go for D option to check for D option over here. So we see D option, that is limit x tends to 0. Okay, and then after integral of 0 to x, that is ft dt. Fine, and that what we call divided by, that is x given over here. You can see the question. This one is D option, this and x square. Okay, so for this, you know, that is ft dt, that is will solve this one, because sin x by x, that is 1. So we will solve this part only, that is 0 to x ft dt x. It means we will concentrate only this part at least, right? So anyhow, so we will solve this part only. So that what we say ft dt and x, because sin x by x becomes 1. So this is applying here Leibniz theorem. So limit x tends to 0, and differentiating above the numerator, that is fx. Once again, we are using here L'Hopital rule, and differential of x is 1, and this result is x tends to 0, f0 is equal to 1. So what we see here, this we are also applying here L'Hopital rule. That's okay. So here also we are using L'Hopital rule. So by L'Hopital rule, we will find this. So D option is, as it is -1, so it's incorrect. So finally, which options are correct? If you see, then the options are only A, B, and C, not D. D is not correct. Okay, fine. So okay, this is question number 4. It is from differential equation, and this is a linear differential equation, LD form. So we will use this as an integrating factor, and here we will make the 2 cases as in this one. So case 1, we will go for alpha plus beta for this one, that is 0, and in this case 2, what we will think about, that is it means that another situation also for constant, we have to evaluate this all. So case 2, we will go for alpha beta not equal to 0. So in one case, alpha plus beta is equal to 0, and alpha plus beta not equal to 0. So better just go ahead and let's start the question. So what we will think here, this is a differential equation, LD form. Fine. So what the solution of LD? So let me use dy by dx plus alpha y is equal to x e power beta x and y of 1 equal to 0. So if e power alpha x is the integrating factor, you can see over here, then let's think about this one, power alpha x integrating factor is equal to integral of x into integrating factor, that is e power alpha, but here that is beta is also there, e power beta x, x beta x. So we have to write x e power beta x. So we just combine this, and we will find this as alpha plus beta into x. That what we will say like this way, alpha plus beta. This is in power actually, and here. So in case 1, if alpha plus beta, we get here this has that it means, let's say case 1. In case 1, what we will think about, that is if alpha plus beta is equal to 0. So let's say if alpha plus beta is equal to 0, you can recall here like this. Okay, so this will be the case 1, you can say. So case 1 is here, that is if alpha plus beta is equal to 0. So in this situation, what we will think here, that is just through point 1 comma 1, and then we can find C, right? So we will get C later on when it will pass us through one y into e power alpha x, this one. And here what we say here is equal to, that is integral of this one, that we say it means alpha plus beta is when we are putting zeros. So integral of x, that is simply x square by 2 and plus c. Now how to find this constant? So think about this constant as it is here. It is given that the curve is passing through point 1 comma 1. So we can see over here as it is passes through 1 comma 1. So let's see. Okay, so if it is passes through 1 comma 1, in this way we can find this constant, and this shows that this constant will provide like e power alpha minus 1 by 2, and that's what C. So what we think about, that is y into e power alpha x. Substituting this constant in this equation, we get here x square, right, minus 1 by 2. This 1 by 2, capture this with x square by 2, and plus e power alpha. Okay, fine. So for alpha equal to 1, so if we think here for alpha equal to 1, as you can see over here, the options are like this way. Transposing that e power x, we say here after this, so x square by 2, right, and e power minus x, divide with this, so plus that we say e minus 1 by 2, and here that we get e power minus x, and this shows that there is a option is correct. You can see over here, this is here. Now let's go for case 2. So for case 2, if we see that we have to consider that is alpha plus beta is now not equal to 0. So if that we say if alpha plus beta is not equal to 0. So in case 2, so that it means that is y into e power x. So what we get here, e power alpha x, and here that is x into e power alpha plus beta into x, right, and divided by, this is like this way, alpha plus beta, and that is minus 1 upon alpha plus beta into e power alpha plus beta x, and that is here dx, we can recall. Now after integrating this, then we will get this result as y into e power alpha x, okay, is equal to x into e power alpha plus beta x upon alpha plus beta here, and minus e power alpha plus beta into, that is x, and that was as it is, and here that was 1 upon alpha plus beta whole square, alpha plus beta, that what we call whole square, and here plus c. Okay, so c equal to, so c, the c provides what c provides over here. So you can see over here, that is this provides c will be equal to, and it means this is c. So we can think here, that is this implies c equal to e power alpha minus e power alpha plus beta upon alpha plus beta, right, and plus e power alpha plus beta upon alpha plus beta whole square. Okay, so now substituting these values over here, c, in this equation, we will get this final result, and here you can think about finally what we conclude that, okay, so y equal to, now we can evaluate by using this whole constant. So let's see, divided by, that is alpha plus beta whole square Okay, and that is what we say alpha plus beta under bracket into x minus 1. All right, and then plus e to the power, we say minus alpha x under bracket. Let's go ahead for this all. Let's see e power minus alpha x. Okay, fine. So what we say here, e power x minus e power alpha plus beta divided by alpha plus beta as substituting the value c over here. So that is e power alpha. That was alpha, no? Yeah. It's not what we say. This is a constant e power c. That is for this one plus c. So substituting this value c over here. So c, as we are substituting e power minus alpha x in c, and that is what we say here for c, that is e power minus alpha x, as we are saying, no? So that we say for alpha plus beta x taken common, and then we will get here e power, yes, alpha plus 1, fine, alpha minus 1. So finally what we say here, plus e power alpha plus beta, and then what we call here alpha plus beta whole square. Okay, fine. So now this is the final result. Let's see over here, this one y. And now if we submit here alpha and beta as 1, alpha equal to beta equal to 1, then we will get this result here. So let's see this one. Then we go for alpha equal to beta equal to 1 in this situation. In this situation, if we put here, that is alpha equal to beta equal to 1. Now submit this value. So we get, that is y equal to, that what we call e power x, as all of them are beta, that is 1. So that is 1 plus 1, 2 whole square, 4, and that is 2x minus 1, correct? So now what we think about this one? So plus e power minus x, okay. And what about this one? So e, that is, let's say, check it out as we will recall here as e to the power, that is also e, okay. So actually this was not x, this was e, no? E power alpha, yeah. Was not x. This one is e power alpha, let's say, because in c that is e power alpha was there. So we submit here, this is as e equal to 1. So minus e power, that is 2 upon 2, 1 plus 1, 2, and here also plus e power 2 upon, and as you know, that is, this one is alpha plus beta whole square, so that is 4, and this is final result, that is 4. Okay, so this is the final result. And what we think about here, that is y equal to e power x, that we check here. So finally we conclude that e to power x by 2, and we can take out 2 common over here, and this is cancelled. So we can think with this option. Let's see over here, this one e power x, then you take out common, that it will just like this one x minus 1 by 2. So if we see for, if we check for C option over here, so we have to take out 2 common over here. Let's e power x divided by 2, and that is x minus, then we can write here 1 by plus e power minus x, and this is as it is e minus, that is e square by 2 and e square by 4, so we'll get e square by 4, and hence this implies that that is C option is also correct. So let's we see over here, you can check that is where the C option. Let's see how these options are correct. So this is C option is correct, and here A option is also correct, as you can see. So finally the result is just like, that is answer is A and C. Okay, so this is our answer to concept, So let O be the origin, as OA is given, OB is vector is given, OC vector is given, or some lambda greater than 0, OB cross OC is 9/2 is given over here, right? So we have to check for 4 options. So first we will get for OB cross OC to make it this equate with 9/2. So let me solve and space at least. So let's shrink this and we can check it out here. That is OB cross OC. Okay, fine. So if you see, then that is OB cross OC for this one. That what we see here. Let us solve. So OB cross OC. Okay, as you know, that is OB cross OC, and that you can see here. This one is equal to half of OB cross OB vector cross OB minus, we can say, that is lambda times of OA. Okay, as we get here, so we can see that is lambda/2 that we call OA cross OB. Okay, fine. So as we know, that is OB cross OC mod. OB cross mod, we have to say OC, that is mod of this, that we say lambda/2 moduli, and that is OA vector mod. Then we have to put our OB vector also mod, but we have to make a multiplication. That's simple. That is we have to consider mod. So as OA and OB are perpendicular. So one thing is that vector OA and OB are perpendicular over here, right? So we can say that while multiplying, that is we can get here, that is 9 lambda/2 as per problem. If you see here, the problem is given, that is 9 times of 2, so 9 lambda/2, and that is equal to 9/2 is given over here, right? So this implies that is lambda equal to 1. So as it is also given that lambda is positive, right? Since this is given that lambda is positive. So what about OC? So think about this one, that is OC vector, what we will recall here, that is OC vector, we can say, then we have to make the projection over here, right? So what do you think about this one? In A option, projection of OC on OA is okay. So OC vector is equal to, what do you say? That is OC vector, we can write OB minus OB vector minus OA vector and divided by 2. Okay, and that is called OB minus OA. So position vector of B minus position vector of A, that is AB vector, we can write, right? So AB vector divided by, now let's let me draw this, that is OM vector and this is OC vector. Now we can see that this is here, there is a M is the midpoint. M is the midpoint of AB. Let's say M is the midpoint of AB here, and note that the projection of this one, projection of OC on OA is equal to, that is minus 3/2. Projection of OC on OA, OC vector on OA, that is OC vector on OA vector is minus 3/2. Okay, so this one is, A option is also correct over here. And now we see for another B option, as you know, that is tan theta angle is, this one is 1/3. Okay, so tan theta is, as you know, that is 1/3. So area of the triangle, we can see over here, that is, we say that is area of triangle ABC, right? That is here we can say 9/2. Fine. So acute angle between diagonals, and what we say here, we have to find acute angle between diagonals. So let's see acute angle between diagonals. Okay, so acute angle between diagonal is given by 1 plus 1 by 3, right? And divided by 1 minus 1 into 1 by 3, that is pi by 4 angle. And here solving we get tan inverse 2. Okay, and that's our result. So, but so check it here. So which options are correct? If we see here the option about options, B and C options are correct. D is wrong. So finally the answer will be here we see. Okay, so this is the final answer. A, B, C options is correct. Now we have to go for another question, sixth question. Sixth question belongs to parabola, and this one we call y-axis. That's it. That is y square is equal to, this one is given 8x. Okay. So from here, if we see this point minus 2, 4, this will be lies on somewhere here in second quadrant. You can see over here minus 2, 4. And from this, when we draw the tangent, so there is two tangents we can draw over here on the parabola. And if we join this line somehow and let this be F, be the focus. So if we see, then here this point is, let's say this be Q and this be Q dash. We have to also check here whether F lies on Q dash or not. So we'll see later on. But first of all, we have to mind this point. This will be the back to this point, and this is the chord. So we can use this chord of contact. So it's a good approach to just go for chord of contact. So using this equation t equal to 0, so that is 4 into y. What we say y1 is equal to, that is 2a. So as you know, that is 4a 8x. So and here 4y equal to 4 into, that is 2a, and here that is x, and passing through this x minus x1, minus 2, x minus 2, right? X plus x1, so x minus. This is the chord of contact. So this implies, so in this way we can get this chord of contact as y equal to x minus 2 after solving. Fine. And here if we put here, this is as x-axis, put x equal to 0, so y you will get here y 0, then x will get 2, so this will be 2, 0, this f point coordinate will be. And in this way, as here this is point P, let's say, as minus 2, 4 is given in the question. If we join P and F like this, then we can find the slope, and slope of this line is here. So if you see here, the slope of line is 1, and we check the slope of line, this one means PF. So we check the slope of PF, or we can evaluate the equation of PF also. So equation of PF, simply we can find x plus y, because it will be helpful also. 2, and from here it is very obvious that the slope is here minus 1 and the slope is plus 1. So we can say this is right angle. So PF and QQ dash are a right angle. So we can say this triangle is right angle, as well as this minus 2, 4 is the directrix of the parabola. So as this is, so this chord subtends right angle at directrix at every point, which is also the directrix. This one, this line will be here, you can say Q and Q dash, which lies on the directrix. So this shows that this will be also right angle. So both the right angle options are correct. Here A and B are correct. But what about C? So we can find PF here by using these two coordinates. So by using distance formula, you can evaluate here. This will be 4 root 2. Minus 2, 4 and 2, 4, x1 minus x2 whole square, y minus y2 whole square, and you can do this and you will find 4 root 2, but here 5 root 2. So C option is wrong. And if you see this, F lies on the line joining QQ dash. Of course, F lies on the joining because this QQ dash passes through the focus, as this is a right angle triangle. So we say that this option is also correct. And in this way we get. So in section 1, if we conclude here, question number 6 from parabola, it's pretty easy if you see they're all based on property, basic level property. And if you see question number 5, that was a vector. Yeah, in a nutshell we conclude this. That was also easy somehow. And this is a differential equation. It's somehow moderate, you can say, but students can do easily. Here the questions which is from L'Hopital rule is again very easy type of problem. So overall, we will rate it as easy as this section 1.